Assalamu alaikum warahmatullah. Welcome to the channel Dr. FMK. This is Khan Fazl and I'm going to teach you General Organic Chemistry GOC. This is the first lecture, and in this lecture we will start with degree of unsaturation. Degree of unsaturation, इसको हम शॉर्ट फॉर्म में लिखते हैं DU. हम बिल्कुल बेसिक से स्टार्ट करेंगे. ये DU होता क्या है? ये वो मॉलिक्यूल्स ऑफ हाइड्रोजन होते हैं which are required to convert a given compound completely to acyclic saturated hydrocarbon. Like, I will write it here. Number of molecules of hydrogen that are required to convert a given compound completely to acyclic saturated हाइड्रोकार्बन, जो कि पहले साइक्लिक होता है और इसको हम बाद में एसाइक्लिक सैचुरेटेड हाइड्रोकार्बन बनाते हैं, यानी कि इसमें कोई डबल बॉन्ड नहीं होता है. आई विल गिव यू हियर एन एग्जांपल. C4H8. We will check that if there is any requirement of hydrogen molecule to convert this into the saturated hydrocarbon, or there is not any requirement. हम ये चेक करेंगे इसमें. This is one molecule. तो इसको कन्वर्ट करने के लिए हमें कितने हाइड्रोजनस चाहिए? अगर हम डायरेक्टली ये लिखेंगे लाइक दिस, C4H8 1 2 3 4 5 6 7 8 means here the valency is completed, here it is completed, here it is also completed, but there is one carbon which don't have any hydrogen atoms. So we will check accordingly how many hydrogen atoms we require for this to convert it into the acyclic saturated hydrocarbon. So we require here two hydrogen atoms, that is one molecule of hydrogen, H and H. So there must be any double bond, or it must be a cyclic compound, so that there is requirement of the hydrogen molecule. So it is Du is equal to 1, which means that there is H2 requirement, which is one molecule of hydrogen, H2. Now we will see for other compounds and we will write here. ऐसे लिखेंगे. डिग्री ऑफ अनसेचुरेशन हम ऐसे लिखते हैं, पाई बॉन्ड्स प्लस रिंग्स. ये हम शॉर्ट में लिखते हैं डायरेक्टली. ट्रिक इसमें कि जब हम फिर बोल सकते हैं इसमें कि इसमें पाई बॉन्ड्स कितने हैं और रिंग्स कितने हैं, उतने इसको हाइड्रोजन मॉलिक्यूल्स चाहिए. अब हम यहाँ पर और एक एग्जांपल देंगे. C3H6. Like we will write here CH2 double bond CH and CH3. This is unsaturated as it contains a double bond. Now we will convert it into saturated, or we can write this in the form of cyclic structure, CH2 and also this CH2 CH2. This is C3H6. Now it requires here, like you have to convert this into alkane. You know CnH2n plus 2 formula for alkane. You have to convert these compounds into alkane, and you have to check the requirement of hydrogen molecules. जितने इसमें hydrogen molecules चाहिए, that is the Du, not the hydrogen atoms, but H2, that is molecules. So we will check here. This is C3H6. It must be C3H8, because if we give here the value C3, then H must be 2 into 3 plus 2, which is C3H6 plus 2 C3H8. C3H6 से C3H8 बनाने में इसको H कितने चाहिए, that is H and H means 2 hydrogen atoms, which is 1 hydrogen molecule, that is it is Du is equal to 1. I hope you got it, and we will check it for different structures. I will give here the example. Like we will make a structure here like this. This is one ring, this is another ring, and like this. And this. Here are 2 rings, and how many double bonds? 1, 2, 3, 4, 5. 5. This pi bonds. This is 5 pi bonds. So Du is equal to rings plus pi bonds. For this molecule, Du is equal to rings are 2 plus pi bonds are here 5, which implies that Du here is equal to 7. And for other molecules, I will give here another example like this, a simple example. Second example, here is only one ring, there is no double bond, so Du is equal to directly 1, because if we break here this somewhere this molecule, there will be requirement of 1 hydrogen molecule, 1 H2 molecule. Now tell me what is the Du of this compound. You know here it is actually C double bond O and H. Here is double bond, and here are here is a triple bond, here is 1 pi bond, and here are 2 pi bonds, and here 1, 2 and 3, like 1, 2 and 3. Three pi bonds and also 1 ring. Now we will calculate its du. Du is equal to, like here, 2 pi bonds, 1 pi bond are 3, and 3 are 6 pi bonds plus 1 ring. So its du is equal to 6 plus 1 is 7. I hope you got it. Now there are also other examples, like when we make a like this, when we make a cube. In the chemistry, organic chemistry, we call it cubane, and it is asked in the exam that what is the du of cubane. You have to calculate this. In this we have a trick. What is that trick? This is du is equal to number of faces minus 1. You have to remember this. Whenever you see any 3D diagram like this cube, or we call it here cubane, you have to calculate du as number of faces minus 1. So what will be the du of this cubane? It will be, it has 1, 2, 3, 4, 5, 6 faces. Du of cubane is equal to 6 minus 1, which is equal to 5. Now we will check here. It was on the basis of structure to find du. Now if the formula is given, like there we will write here a general formula, and you have to convert that formula into, like the I told you before, into an alkane like structure. Like you have to find it as du. There's a formula CnHy and AX. Like how there is any other atom like A other than hydrogen and carbon, and its atoms are X, and the atoms of hydrogen are Y, and the atoms of carbon are N. You have to convert it into like this. Cn, carbons are the parent in the parent chain, which remains unchanged here, but the number of hydrogens will change if you calculate du and if you add the hydrogen molecules. Now we will check it here on the basis of formula. We write it like how many hydrogen atoms are needed there. We write it 2n plus 2 minus z. We have to minus this z from 2n plus 2. This z we have to minus it. Like I told you, CnH2n plus 2. This is the 2n plus 2 of actual alkane like structure. That's why we have to subtract this z from 2n plus 2. Now we will calculate du. These are the number of hydrogen atoms, but we need hydrogen H2, that is molecules. So we have to divide it by 2. du of this will be delta H, like how many hydrogens are needed there for du, divided by 2, that is 2n plus 2, and we will subtract z from this, then divide by 2. So you know this n, it is the number of carbon atoms, this is the number of carbon atoms, and z is the number of hydrogen atoms which was present in this here. So according to this, we will write it as the carbon and hydrogen atoms du is equal to, that is 2 times carbon atoms, and we have to add this 2, this is here the carbon atoms, and we have to subtract the hydrogen, then we will divide it by 2. This is the general formula for calculating du. It was the general formula for calculating du if formula is given, but it has different parts. What if the compound contains some monovalent atoms? Compound contains monovalent atoms like X atoms, we will denote it by X, like this, C, N, H, Y, and X is, we will denote it here L. This is the atom, and these are the monovalent atoms. Firstly, we have to remember the steps in it. हमें यहाँ पर इसको रिमूव करने हैं. X atoms, remove X, then second add same number of hydrogens. For example, हम यहाँ example देंगे like C4H6Cl2. इसको हमें कन्वर्ट करना है एक अल्केन में, और इसको हमें देखना है कि कन्वर्ट करने के लिए कितने हाइड्रोजन मॉलिक्यूल्स लगेंगे. इसको हमें बनाना है पेरेंट अल्केन, जो इसका अल्केन होगा C4H8, ये हमें बनाना है. उसके लिए हमें क्या करना है, -Cl2 किया हमने, फिर हमें देखना है कि कितने हाइड्रोजन एटम्स इसमें लगेंगे, उसका मॉलिक्यूल देखेंगे फिर. तो इसको यहाँ पर लगेंगे हाइड्रोजन 2 एटम्स विच इज़ 1 मॉलिक्यूल. which implies that du of this molecule is 1 because it requires only 1 hydrogen molecule. It was the monovalent, so you have to remove the atoms, this, and directly add the hydrogen atoms. But if there is a divalent atom, like oxygen, O, or sulfur, हम यहाँ फॉर्मूला लिख लिखेंगे CnHYOM. This is the general formula here. We have to directly remove the divalent atoms. Like अगर हम CnHYOM लिखेंगे यहाँ पर, इसको हमें माइनस करना है OM, which will make it here CnHY atoms. For example, C3H6O minus oxygen atoms. It will make it here C3H6. So its du is equal to 1 because we had to remove one oxygen atom. After this, if the compound contains trivalent atoms like nitrogen or phosphorus, like this CnHY, N is X times. We have to remember this. First, remove the trivalent atoms. And secondly, also remove same number of hydrogen atoms. For example, C2H3 and N. We have to remove here the nitrogen. So the number of atoms we remove, that is the du for this compound. We remove one atom and also hydrogen, that's 2 atoms. It will make it C2H2. That is the du of this compound is 2. We can make a general formula here now for all the compounds, like CnHY. This is monovalent atom L times, and also divalent atom M times, and trivalent atom X times. We will make it this CnHY plus L, because we will add same number of monovalent atoms, and minus X. Now we will make a formula for this. Du is 2n plus 2 and minus y plus L minus X, and it is the hydrogen atoms all here will divide it by 2. Now what is the du in last? That is 2 carbon atoms plus 2 and minus, that is hydrogen atoms plus trivalent X minus N and whole divided by 2. This is the general equation for all the atoms like monovalent, bivalent and trivalent. This was all about here the du.